Okay, we're doing problem 6 from the worksheet for, or example 6 from the worksheet for section 6.5. We're told we have an ice cube that has sides of length 7 centimeters. It is melting, and so the volume is changing, and they tell us that it's changing at a rate of 4 cubic centimeters per second. Per second or minute, let me double check that. Per minute. Let me fix that. 4 cubic centimeters per minute. Okay, and we're asked to find the rate at which one of the sides is changing. So I've labeled it x, even though it says it starts at 7, we know that it's going to be shrinking, so we'll just call the length of one of the sides x. Since it's a cube, all of the sides are the same length. So we're told the volume, we're told that it's melting, so the volume is changing. This is the rate at which the volume is changing, and we want dx dt, the rate at which x is changing. So the relation between these two, it's a cube. So what's the volume of a cube? X to the third power. And what we want is the derivative of that dv dt. The rate of change of the volume with respect to time, so that's 3x squared, and then remember that x is a function of time as well, so we need its derivative, dx dt. Okay, now we want to know dx dt, so we have to solve for it. So dx dt by itself, we're going to have to divide by this 3x squared, so we're going to get 1 over 3x squared, multiply that by the dv dt on the other side, and we want dx dt. Actually, let me double check one. Does it say we want it? How fast is the length of the side decreasing? Okay, so it doesn't give it at any particular time, so we want dx dt. I guess when x is 7, since that's what it says. So we'll just go ahead and put 7 in there. And dv dt is -4. And let's put that in our calculator, so we'll get 1 over 3 times 49. And we'll multiply that by -4. And that gives us -4 over 147. And we'll get an approximation for that as -0.02. So approximately -0.027. And the units on that are going to be centimeters per minute. So pretty slow. The side length is going to change at that rate, about 2/100ths of a, or about 3/100ths of a centimeter every minute, if the volume is changing at that rate. And again, that is only going to go for basically the moment that it starts melting, when it has that side of length 7, as is given in the problem. As it decreases, as the volume decreases more, the sides are also going to decrease faster, because you can see that if that 7 gets smaller here, then we're going to have a larger value here, and so you can see that dx dt will actually increase at or x will actually decrease at a faster rate once it shrinks more. So as time goes by, the x will decrease at a faster rate than this. Okay, as we kind of expect from an ice cube shrinking anyway.